All right, how many of you know something about unstructured data? Thank you. How many of you would like to know more about unstructured data? Awesome.
I want to know more about structuring data.
Structuring data, okay. Well, my name is Craig Golightly, and welcome to Adding Structure to Unstructured Data. So, first of all, we'd just like to thank UVU for giving us this great location. Let's give the guys at UVU a hand. Thank you. Okay, also, you guys no doubt have a lot of people back at the office, back home, taking care of things so that you can be here. Let's give them a hand as well. Okay, and finally, all of you, you made it. You got through the mile-long hike to get here from the parking lot. You found the seats. Go ahead and pat your neighbor on the back and say, "I'm so glad you're here." Awesome. Okay, so today we're going to learn about text analytics and speech-to-text, what it is not, how that fits into unstructured data, and how these are tools to add some structure to these things so we can get more valuable insights out of it. We're going to talk about the strengths and weaknesses of these tools. We'll also look at unstructured data overall and how to improve our use of it. How many of you want to learn about these things today? Excellent, thank you. Okay, I'm going to use some real-life examples, tell some stories. There's even going to be a test, but don't worry, I'm not going to be giving any grades. My goal is to help you see if text analytics and speech-to-text can help make your life easier by reducing those repetitive, mundane tasks and turning a data dump into a gold mine of information. Everyone turn to your neighbor and say, "I so hope you save some time with this." Thank you. Okay, we're going to play here, all right? You're going to be ready. Okay, do I have permission to share some information with you about myself?
Sure.
Thank you. So I have a bachelor's and master's degree in computer science. I've been in software development for over 10 years. I've handled unstructured data for companies like Arby's and Comcast and Hertz, several different large companies. Over the past year, I've presented on this topic at a conference in New York. I've written a few different blog posts. I'm also a featured author in this book, Achieve. I mentioned it a little bit in here. So yeah, this is an area that I'm very excited about the possibilities for people who harness this data and can turn it into something. So as we get started here today, we're going to have 3 rules. How many?
3.
Excellent. So the first one, respect. Okay, so everyone turn to your neighbor and say, "I will respect you until 11:25 today."
11:25 today.
Awesome. Thank you. Okay, the second, present. Okay, we have the past, the present, and the future. So as we go through the presentation today, your neighbor's brain might kind of wander around. So there might come a point where you're going to have to take your neighbor's brain and put it back into their head for them. Okay? So everyone, grab your neighbor's brain. Okay, put it back into their head for them. Okay, got to make the sound effect. Okay, and then finally, we need to manage our communication devices. So, this may be the first presentation for a lot of us. So, make sure the cell phone is there on silent, and we won't have any interruptions for what we're going to do today. So, how many of you will follow these rules? All right, thank you. Okay, so I personally guarantee to give you guys 100% of what I have today. Okay, the information, the enthusiasm, the things I've prepared, I personally guarantee to give you guys 100%. So in return, I'm going to need you guys to play at 100% so that you can get everything that I'm dishing out here today. All right, who's ready to play at 100%? Awesome, thank you. Okay, so to start out here, okay, has anyone been to a drive-through? Okay, drive-through, everyone knows what I'm talking about, right? Does anyone not know what a drive-through is? Okay, good, we're all on the same page here. Okay, has anyone ever messed up your order? Messed up your order? Okay, so I love this. I go to the drive-thru, and my kids, it's like they're speaking a different language. You know, they pull up, and then all of a sudden they turn into like this robot. I want a cheeseburger plain. Because they've learned that there's no plain cheeseburger button with the guy on the computer. Where was the UI design on that? Come on. So they've learned they have to alter their manner of speaking so that this guy can get that data in there how he wants it. So I was listening to some surveys, some voice surveys. We were combing through them with some tools, and we came across an interesting one for a certain restaurant that I'll try not to let the name slip out. And so this guy, so this was a survey. You know, you get on your receipt, call this number, and get a free sandwich, right? And so he had called up. This is being recorded, so I'm not sure like what this guy was thinking. But he's like, yeah, they were really rude. And then at this point, he just like snapped. And if I ever see that person again, I'm going to kill them. So this guy is issuing death threats on this recorded survey. Something you want to catch, right? You know, you've got 10,000 of these voice surveys to go through. You know, these are the things you want to get. Well, apparently what had happened is the worker at the drive-thru, for some reason, had taken his milkshake and like thrown it on his car. It just went all over the car. And so, you know, he was mad, but come on, guys, it's a milkshake and it's a car. Go through a car wash. You don't need to kill people, right? So let's take a look at the unstructured data here. Let's see how this plays into this story. Okay, so first we have our survey. You know, it's an audio survey. He calls in, it gets recorded. Then this gets sent over to some human transcribers, and then they're going to turn it into text. Now, transcription, human transcription has a couple of limitations. One, it's quite expensive, $1 to $2 per minute to get good quality human transcription. The second one is time. Generally, the turnaround time on these things, people will batch them up and do, 1 to 2 months. So in 1 to 2 months, you're going to get, what this person said. Then it's got to go to this poor guy. So here's our manager. He's not a happy camper. Why is he not a happy camper? He's got to read through 10,000 of these transcribed comments to try to make some sort of sense of it. Think about a large multinational or international organization. They're going to have hundreds, maybe thousands of data points of these, transcribed surveys or, any other data that has been turned from speech to text. Now he's got to somehow sort through that and make sense of it and aggregate it. And then, let's say he was lucky and he found this guy that was really mad. So maybe he's going to call him up on the phone. Maybe he's going to call that guy and be like, hey, I'm so sorry you had a bad experience that, this milkshake got thrown on you, on your car, and you can just hear the guy on the other end, this has been probably maybe 3 months if we're lucky that this has transpired. Be like, oh yeah, oh man, I forgot to go back and kill that guy. It takes too long. Plus, is that employee okay? No one knows. It's been too long. So this whole process here is maybe happening once a quarter. Just for different, for various reasons, for time, for cost. Once a quarter, people are putting their surveys through. Okay, so one of the things that we need to do here is come up with a new process using some different tools. So let's look at how we can change this process from being once a quarter to being much less than that. So we're still going to have our same survey of our audio survey. But now instead of going to humans, we're going to have this go to some machine transcription. And it will produce our text. we're going to put this through something else. Okay, we're going to apply some text analytics to these 10,000 surveys. What that's going to do, that's going to make this guy happy. Because now he has a report. He has a report that he can get his information from. And now he can go ahead and give that guy a call. He can spot negative things that need to be improved. He can spot positive things that need to be reinforced. You know, someone's doing a really good job and someone gives them a great feedback in a survey. Well, you want that employee to keep doing a good job, right? Someone's doing really bad. You want to go talk to them and make sure they're not doing that to other customers. How many other people had a milkshake thrown on the front of their car? You know, we don't know the answer to some of those things. But as we tighten this up, this whole process can happen in 1 to 2 hours instead of just once a quarter. There's some seats right over here if you want to come over and have a seat. Okay. So it's very key that we tighten up this loop. You know, who wants their problems to take 3 months to solve versus maybe 3 hours? I know for me, I want things to be solved sooner. I want a tighter feedback loop. I want that to happen faster. Okay? So one of the things that we run into when we're talking about these tools, we're gonna kind of pair ourselves against the machines here. So I'm going to pass out some different colors of paper here. Just kind of take one and pass it to somebody else. And don't look at them yet. Okay? So I know some of you are going to, but just pass it. Leave it face down. Okay? So we're gonna pass out some of these. Just kind of take one, pass them around. Okay, we'll get them around here. So you guys, okay, just everyone needs a paper. Just take one and pass it around. If we have some extras, that's fine. You got one? Okay. Okay, we got it. Getting them to the middle back here. Okay, raise your hand if you do not have a piece of colored paper yet. Everyone got their colored paper? You need one? There you go. Anyone else?
We need more over here. Pass the extras down.
Yeah, if you've got extras, just hold on to them. Oh. We're good. Okay, so everyone's got their paper, right? When I say go, you're going to turn it over and you're going to quickly read it in your head 2 times. Then you turn it back over. Okay? So everyone ready? Go. Okay, reading it the first time. Reading it the second time. Okay, stop, stop, stop. Turn it back over. Okay, so now we're going to do a little something here where I need everyone to stand up. Okay, go ahead and stand up. Okay, give you a second to get the laptop situated so no one's going to knock them over. All right, so now you're going to turn the paper back over. Now everyone has different colored of papers. Turn it back over and count the F's. Okay, turn it back over and count the F's. Okay, go ahead. If your paper has 3 F's, I want you to come up over in this corner here. Okay, so go ahead and start moving. 4 F's over there, 5 in that corner, and 6 in that corner. Okay, count the F's on your paper. 3 right here, 4 over on this side, 5 in that corner, and 6 in that corner. Okay, go ahead and quickly move to those. 3, 4. 4 is over there. 5 and 6. 3, 4, 5, and 6. Once you get there, just kind of hang tight.
Where's 3?
3 is right over here. Okay, 3, 4, 5, and 6. Okay, once you've got there, just stay where you're at. All right, we got everyone sorted here. Okay, all the 3s, raise your hand. Okay, excellent. 4s, 5s. You guys all 5s and 6s. Okay, excellent. All right, so someone who had 6 Fs on their paper, can you please read that out loud?
Finished files are the result of years of scientific study combined with the experience of many years.
Okay, thank you. All right, someone who had 5, go ahead and read your paper. Okay, read it out loud.
Finished files are the result of the years of scientific study combined with the experience of many years.
Okay, thank you. Someone with 4 Fs, go ahead and read that out loud.
Finished files are the result of years of scientific study combined with the experience of many years.
Okay, excellent. And someone with 3 Fs, read it loud and proud. Who's going to read that for me? All right, there in the back.
Finished files are the result of years of scientific study combined with the experience of many years.
Excellent. Okay, so this is usually how it shakes out whenever I do this. We have a huge majority over in 3, little bit in 4 and 5, and then a handful in 6. So what happens here is as you're reading it, the F's in the of sound like a V. So we're influenced by what we hear more than by what we see. Okay? So all the papers are the same. They all have 6, but they're different. Okay? Give yourselves a hand for counting the F's. Good job. Okay, go ahead and return to your seats.
We changed the color so people think it's different. It's nice.
Different colored papers.
Okay, you guys are the smart ones over
All right, so from that exercise, we see that consistency is not a human strength. Right? That's not something we're real good at. We're easily influenced by a lot of different things. And so when we're dealing with these mountains of unstructured data, we want to have a consistent, repeatable way to run this stuff through and get some different information. You know, you've got 100,000 different comments. You don't want to have some guy or even an army of guys reading that because it's going to be inconsistent. You want to set up your equations, set up what you're doing, run it through, see how you like it. Okay, let's adjust a few things here. Then run it through again. Okay, so this brings up something that is always talked about when we're talking about text analytics and speech to text and all of these unstructured data tools. The question that people always ask is about accuracy. Well, how accurate is it? Can I trust this, this software with my data? Is it really going to work? So unstructured data, it's a hard problem. There's no other way around it. And what constitutes accurate isn't always clear. A lot of times people will say, well, what the humans do is 100% accurate. And as we see, not always the case. So SproutLoop.com took 100,000 tweets and had the sentiment of each tweet categorized by 5 crowd workers. How many crowd workers? 5. Okay, so we're talking a tweet, very small. They took the same tweet, gave it to 5 different people, gave them a selection of buckets that they could put it in. There was a list, a finite list that they could say, oh, I think this tweet is most this sentiment right here. So 100,000 tweets, 5 people each. Guess how many times all 5 people agreed? What do you guys think? Just 20%? 80? 0. Any others? Okay, so they agreed 44% of the time. So that's what we call inter-rater agreement. So when you're sending stuff off to get it crowdsourced, Mechanical Turk or different things like that, it's very important to measure your inter-rater agreement. How often, what percentage of the time do the people agree among themselves? Because your overall accuracy of that particular algorithm or that particular process is limited by how much they're agreeing with each other when you're using that. So one of the default equation that people use when they're talking about accuracy in these tools is if accuracy is less than 100%, then that is a fail. We're really good at picking out things that are wrong, aren't we? Anyone here have kids that bring home a report card? Okay, the kid brings home a report card with five classes. Let's say 4 of them were A's and 1 of them were a C. What do we jump on? Oh, what was this C? What happened here? Wow, he got 4 A's. This is cool. What did you do right in these classes? Keep doing that. Yeah, don't worry about this one. It'll take care of itself. That was probably like, one of the other classes that weren't programming. I think I can say that in this room, right? That was the English class, the one that they fell asleep in. So, not to just, I did a fair number of English things too. I actually learned more about English taking Latin. So, go figure. So this is a very tough equation to live up to because, like we said, it's tough to get even people to agree, let alone a software algorithm. So in order to get some good use out of this technology and not miss out, we need to change the equation. We need to change the what?
Equation.
Okay, one more time, twice as loud. We need to change the what?
Equation.
We need to change this equation. We need to say if accuracy is greater than 0%, then that's a win. Can we get anything out of this? Because most of the time, the data is just sitting on a server somewhere. We're paying it every month. And oh, sweet, Amazon came out with Glacier storage. Now it's even cheaper to keep this stuff forever that I'm never going to look at, right? It's expensive to hold this stuff around and not do anything with it. So if we can get any value out of it, then we should be pulling it through. We should learn how to deal with the inaccuracies. If we wait for it to be 100% accurate, then we're going to miss out on a window of opportunity to use these tools to gain some valuable insight. So a key thing to remember is, text analytics, speech to text, they're just tools to give different views into the data. We're just looking at it from a slightly different angle. They help us see the data faster. They help make it more understandable. Digest those 10,000 comments into one report. Scan those calls that are coming in real time and look for things like death threats or, somebody slipped and fell on a floor. Uh-oh, there's a lawsuit waiting to happen. There are certain known categories that we can monitor and look for. But then the other cool part is the unknowns. Text analytics and speech to text allows us to look at these things and find some unknown things that we weren't expecting. So we monitor the known and we discover the unknown. Okay, monitor the known and discover the unknown. Thank you. Okay, so let's see. I'm going to skip this one part here. We're going to go into talking about evaluating unstructured data tools. Just real quick, unstructured data, does someone want to just kind of shout out, what are some examples? When we're talking about unstructured data, in fact, just raise your hand if you want to give us some things. What unstructured data do you deal with? Or maybe not personally, but just what are we talking about here when we're saying unstructured data? Sir?
It could be anything. It could be a PDF document. It could be a Word document. It could be a natural text that came from the speech. It could be anything. A plain, natural language could be English, could be something else, any other language.
Exactly.
At the end of the day, it's a pure text.
Excellent. Okay, give him a big wahoo. Wahoo. Okay, sir over here.
I have a lot of family history, audio and video, and talks and stuff like that from family members and things that there's no way I can search without just watching them all.
Right, lots of recorded audio. Going to get some stuff out of there. Excellent. Give him a big wahoo. Wahoo. Okay, anyone else? Sir?
I'm doing the same as you, what we call open-ended questions and surveys. As well, people often want me to be able to parse and read emails and structure that.
Yeah, excellent. So open-ended questions, emails. Okay, big wahoo. Wahoo. Okay, anyone else? Any other unstructured data? Sir?
Survey limit averages, disk space, etc.
Excellent. Good. Okay, big wahoo. Wahoo. Okay. So, social media is a hot one right now. it's debatable about the value of that, but there are some nuggets that can be found while sifting through this mountain of material. And the only way it's going to happen is with using these tools. I've met people that they have a department in their company, and they are like manually tagging tweets. They're getting in anything that mentions their company, and they're reading them all by hand. Like, talk about wanting to pull out your hair, That very repetitious, very subjective, right? If that person's kind of tired, maybe they're going to classify things, they might miss things. You want to use these tools to take advantage and kind of filter that information as it's coming through. One funny story, I don't know how many people you guys have heard this, but there's a guy by the name of Peter Shankman, and he travels a lot. He's got probably 100,000 Twitter followers. He was flying back from Florida one day, back to New Jersey, and he's a frequent diner at Morton's Steakhouse. Anyone ever been at Morton's Steakhouse? Kind of like, they have a few places. So when I was in New York this March, I went there just because of this story that I'm about to tell you. And it was really good steak, like, whoa, like melt in your mouth, okay? So anyway, as a total joke, he tweeted, "Hey, at Morton's, can you meet me at Newark Airport with a porterhouse when I land in 2 hours? Okay, thanks." Just one of those things that people randomly put out in tweets like, "Hey, universe, thanks for raining today." Or, he had absolutely no intention of that doing anything but just going out in the ether and just, this is kind of a funny thing to say. So he lands at the airport. That's all the information that he gave. He just tweeted that out there. He didn't give his flight number. He didn't say when he's arriving. Just that was him on his account. So he lands at the airport. He's going over to where his driver is, and there's another guy in a tux talking to him. And he thought, it's probably just another driver. He gets up closer. It's a waiter from Morton's Hackensack. He's got a bag. In the bag is a porterhouse steak, some sides, everything right there. Hands it to him. He's like, "Here you go, Mr. Shankman." And it totally blew him out of the water. I mean, he's tweeting it right there, taking pictures. Now, would they have done this for any Joe? Probably not. I mean, did the fact that he had 100,000 Twitter followers maybe influence this? I'm sure it did. But Morton's had something in place that they were listening for that social media. They were able to identify a high-value client. It's not like it's his first time there. He is a very frequent person. He's registered with them. He's very engaged with this company, very loyal to this company. And they're like, "Hey, this is a great opportunity to show that we really listen to our loyal customers and we take care of them." And so, these tools that we're talking about, the text analytics, speech to text, those things allow us to be able to find those little nuggets that could be great to capitalize on from all of the other noise that's out there. The other place is customer service calls. The industry average is kind of between 1% and 5% of QA. So any call center that you call, 1 to 5% of the time, there actually is a manager or a supervisor listening in on the call or listening to those recordings. Every place you call, this conversation may be recorded for quality assurance purposes, right? Yeah, right. How many times is somebody actually going to listen to that? 1 to 5%, it turns out, is the industry average. And so you've got the other 99 to 95%, all of this other stuff not being listened to. So with a speech-to-text tool, you can actually have 100% monitoring. So the speech can all be fed through a speech-to-text appliance, and then you can be doing the keyword spotting, right? There's a couple of different things, and I'll talk about this in a minute as we evaluate. But again, you can at least look for the knowns. Now, if you turn that speech into text, then you're able to start to discover some unknowns. Are there things that we weren't expecting happening in these conversations? So evaluating unstructured data tools. Let's talk about this. So when we're evaluating different text analytics tools or big data tools or speech to text, phonetic search, the first thing that I'd recommend is the maturity. How long has it been around? For open source projects, how active is the project? Is it 5 years old and there's been a couple commits, or does it have an active community around it? How many times has it been used, downloaded? That can give you a good sense of how robust is this tool? How battle hardened is it? Have they shaken out the bugs yet? Okay. The next one is the features. Okay, do the features add something of value to your process, or is it just kind of a cool feature? Some things, when we're dealing with text, is it a purely statistical analysis, or is it a linguistic analysis? Does it take into account the lexical chaining in the text? Does it take into account the parts of speech and the special relationships that may be there? Can it go through and find imperative commands? A company that I do a lot of work with is called Lexalytics. They have a text analytics engine. They were the first ones to come out with sentiment in text 10 years ago. And so one of the things that they've developed was imperative command finding. So think about that manager that you send an email to and you never hear back from him, right? This sorts through that data and finds the imperative commands, like, oh, I need you to send me this, or hey, can you get this taken care of for me? Those action items, it will go through and identify in the email text, okay, these are the things that look like they're action items. And then it will present, this summarized, this distilled version of maybe 100 emails, and then he can at least take care of those and then go back and see what it missed. Again, not going to be 100% accurate. Anyone who's claiming 100% accuracy is given a sales pitch, because it's just not there yet, but that's no reason to throw it out the window. Categorization is another thing with text. A unique thing that Lexalytics has done is they've analyzed Wikipedia and all of the different ways that people link things together in Wikipedia. And so how do we talk about fruit? If I say, I want stuff that's fruit, well, it goes out there and says, okay, what things are linked to fruit? Well, bananas are, and apples, and pears, and mango. And so if I feed text into it and I say, I want a bucket of fruit, it will go in, and if my text has like mango or pear, it'll throw it in that fruit bucket. So it's using those relationships, that categorization that humans think about on Wikipedia, how we link things together, and it has grabbed that and created a model so that we can then use that to categorize our other unstructured data in a similar manner. And so that's been a cool thing to watch come together. Sentiment. Can we get positive, negative, neutral? A word on sentiment, there has to be a neutral, okay? You can't just say positive and negative, or you're going to get all sorts of misclassifications. Depending on the data that you're running, you're going to have to maybe widen that neutral. Sentiment is most useful for identifying very good things, so people that were really happy, really excited about something that happened, or very negative things. Someone is really ticked off about something, and they want to let you know. Those little outliers often are the things that we can take action on and get the best return. And so sentiment isn't meant to, be a magic wand and get something down to the, very, very precise. It's more, you've got this sea of neutral, and on each ends, you can find some of these outliers, automatically spot them as they're running through your data. Let's see, intent is another one. So for speech, there's a couple of different types of speech. When we're dealing with unstructured data, of speech analysis tools. The one is phonetic search, and so that's looking at the sound waves and purely at the phonetics of it and saying, okay, and you have to know what you're looking for. So this is a monitoring the known, is phonetic search. Unfortunately, a lot of phonetic search, it has its own data format. The insights you get are locked up. A lot of times the data footprint is very large for the number of machines, licensing costs. Speech to text, on the other hand, uses a phonetic to identify things, and then it has the vocabulary of what are the possible words that these sounds, that these acoustics match. And so then you're left with the output of text. Then you can feed that into your regular text analysis tools to discover the unknowns as well as monitoring the knowns. And so those are a couple of different things to look at when you're considering features. So the next thing is your speed and scalability. So I'll just put speed and scale. some things were designed to be just desktop apps, so they're going to be ill-suited, for an enterprise-grade application. A speech-to-text that was designed to run on a desktop for a single user, that's not going to scale to a call center with 100,000 agents. As well as the speed. How long does it take? 4 years ago, one technology, a speech-to-text from a very well-known large company, they actually had to slow down the audio to like 60% real time in order to get, in the 60% accuracy. And so it's like, hey, we're getting thousands of hours in calls. We're never going to catch up, or we're going to have to buy, a building full of hardware to keep up with it. Different solution from a company called Voci. They have a hardware appliance, a single like 2U high server, used FPGA technology. It could process 100 hours in 1 hour. Okay, so everyone blink your eye. Okay, it just transcribed a 30-second comment. Okay, that's how fast. And so that type of thing, very small footprint, comes through, very easy to scale, and it has the speed to keep up with real time as well as very large numbers of audio files. The next thing I kind of mentioned earlier, openness of data. I'll just call it open data. Okay, this has to do with what is the format that tool spits out its data in. Is it locked up in some proprietary format? Is it just plain text? Is it, in a bunch of database tables that is their own schema and you don't have any control over it? How easy is it to access that data? The audio files. If you want to re-listen and find something right at the precise moment, to say, did this guy really say he was going to kill the person? As well as what metadata is included in the analysis. For speech and text, if you can get a measure of confidence, that's very good. So how confident is it in this transcription or in this tag that it made from the text analysis? Then you can use that as a filtering to say, okay, well, we find that anything below 70% confidence is really quite noisy for us, so we're gonna ratchet our filter up and only take things that pass that threshold. If the tool that you're using doesn't provide some sort of confidence scale, then you just have to take everything and try to sort it through. And so, where we've accepted some inaccuracy in the process, it's important for the tool to tell us, hey, this is my best guess of how accurate this was. Then we can decide how much of that data or how little of it we want to use. And then, confidence, sentiment, timing. Okay, tunability, our last two here. How easy is it to fit the tool to our process? Or do we have to go over here and completely redo our process to fit this tool? That really plays into the last one, which is, I wrote a C because it's cost. This is a big one, and this is one that throws people off because they're looking at the wrong part of the cost equation. So most of the time, it's only the licensing cost that's considered, but you have your data center footprint as well as the development cost. What kind of configuration are you going to have to do? What kind of infrastructure do you have to build up to use this? Do you have to completely change your process to fit this tool, or can you just plug the thing into your process and start using it right away? And so the cost is a very important thing to go through and consider. So just in closing, we generate and consume massive amounts of unstructured data every day. It's very tedious to sort through, and reaction time is just too slow. We want our problem solved, 3 hour, not the 3 months. The data is expensive to store, and worse yet, a lot of times it's stored and never looked at. And we need to glean some insights and process it in a way that saves time and improves our results. Instead of getting buried by unstructured data, let's make something out of it. Go ahead and give yourselves a hand for being here today. Thank you.